Question 27 tells us that y equals f of x is a line with negative slope. Which must be true? We're given three options. Notice that this question is asking which must be true. This means that if you can come up with a case where one of these three options is true, it's not good enough to pick it as the answer, because you have to show that the option is true always. In other words, the option has to be true, not simply that it can be true. When we consider a line with a negative slope, there are three main situations to consider. You can have a line with a negative slope like this one that goes through the origin, but you can also have a line with a negative slope that has a positive y-intercept, or a line with a negative slope that has a negative y-intercept. It's important to be aware that all three of these scenarios are worth considering, since the answer that we choose has to be true for all lines with a negative slope. The most straightforward situation to consider is the situation where the line passes through 0, 0. So that's what we'll start with. Option 1 says that if a is less than b, then f of a must be greater than f of b. Well, we can consider two values, a and b. Perhaps a is here and b is here. This meets the criteria that a must be less than b. We can then ask ourselves, is it true that f of a is greater than f of b? Well, f of a is here, and f of b is here. So it seems like in this case, f of a really is greater than f of b. But again, we've just shown one instance where option 1 is true. We have not shown that it must be true. We can consider other values of a and b. For instance, maybe a stays where it is, but now b is positive. With b in this new location, f of b is here. Is it still the case that f of a is greater than f of b? Yeah, it is. We can do something similar in scenarios where the line has a y-intercept that is not at 0, 0. In other words, if we move the line down here, for instance, and then we pick values for a and b, so long as a is less than b, is it still the case that f of a is greater than f of b? It seems like, yet again, things work out. You can try testing this in the third scenario yourself, where the line has a positive y-intercept and perhaps looks something like this. You'll find that in all three cases, option 1 is true. As long as a is less than b, f of a will be greater than f of b. Let's move on to option 2. If a is less than 0, then f of a must be greater than 0. We can see in the simplest case that as long as a is less than 0, f of a will always be greater than 0. However, let's imagine that the line moved. For instance, maybe this line is the line we're talking about. In this case, a is less than 0, but f of a is not greater than 0. Because we've shown one scenario where option 2 is not true, we can rule it out, since we can only pick options which must be true. In other words, which are always true. Looking at option 3, if a is greater than 0, then f of a must be less than 0. Again, going back to the simplest case, where the line passes through the origin, we can see that if a is greater than 0, f of a is indeed less than 0. However, let's consider a different case. What if the line has a negative slope, but passes through a positive y-intercept? In this case, a is greater than 0, but f of a is not less than 0. So option 3 must be false. This leaves us with option 1 as the answer, since we were able to find counterexamples to the claims proposed in options 2 and 3.